Hi, welcome to Essential IT and Security Skills. I'm Charles Redman, Master Trader, here to guide you through the essentials that you are going to need to land the job that you are looking for. In this series, we're going to talk about essential PC skills. I'm going to walk you through everything from software to hardware. Most people know me as a cybersecurity expert. Well, I couldn't have gotten there without learning the basics first. That's what this series is going to do. And then we'll move on in some later series with some more advanced concepts and techniques. But remember, it all starts with the basics. It starts right here, the essential PC skills. We're going to explain the functions of the BIOS, distinguish among various types of CMOS setup utility options, describe option ROM and device drivers. We'll learn how to troubleshoot the post or power on self-test, and how to maintain your BIOS and CMOS properly. So the BIOS, or Basic Input-Output Services, is on a read-only memory or ROM chip, also called the system ROM or ROM BIOS. It's non-volatile, which means it doesn't lose its programming if there's no power, and it's not easily erased. The system ROM typically only holds about 64K of code, which makes it rather small in size, about 2 megabytes. The CMOS, or Complementary Metal-Oxide Semiconductor, is part of the South Bridge. It's considered part of volatile memory, which means it must have power to maintain its functionality. The CMOS helps the system maintain an accurate date and time. It's customizable. The setup program is stored on the ROM BIOS, but the customizable settings are on the CMOS chip itself. It stores semi-permanent user-changeable data. Option ROM, or Bring Your Own BIOS, is individual to specific types of devices that you have loaded onto your machine. It's the device drivers loaded into RAM at boot time. The device drivers are little files stored on your hard drive that loads all the BIOS commands for that specific type of device. It will come with the device as an installation disk, usually either on a floppy or CD-ROM. Let's discuss the power on self-test, or the post. At boot time, the ROM initiates the post process. The post routine sends out messages to all assumed components to wake them up or determine whether the components are working properly. If any single component fails, the post process halts and sends an error message. These error messages are indicated by beep codes. For instance, if video is missing or faulty, you'll hear one long beep followed by 3 short beeps. If RAM is missing or faulty, you'll hear a rather alarming beep or buzzing that will repeat as long as the computer is on. But if the post completes successfully, you'll hear 1 or 2 short beeps. Errors are usually displayed in clear text, though they can sometimes be rather cryptic. Text errors are far more useful than beep codes because you can simply read the screen and determine the bad device. Here is what one of those would look like. PC techs use what's called a post card. It's a small expansion card that you're going to install into an available slot on the motherboard. It's used to monitor the post process. It has an LED display so you can see what device post is currently checking. Then it'll display the code. This can help you immensely trying to help identify the faulty components. However, it's important to understand that the post is simply looking for hardware problems. If the PC passes post, the problem is more likely a software issue. Postcards used to be an essential part of every tech's toolbox. However, today they're very rarely used. If the postcard shows no reading, then again, it's more related to the CPU than it is the hardware. Here's a look at what a postcard looks like. Notice the expansion card on the motherboard and the LED display to show you where it is in the post process. Now let's walk through the boot process. The first thing that your PC is doing during the boot process is to check power supply voltage. If good voltage is found, then it sends a signal through the power good wire. This wakes up the CPU, which in turn sends a built-in memory address, which is the first line of the post program on the system ROM. Now, the ROM can begin the post routines. Once the post is passed, the ROM begins the boot process. At this point is when it's looking for the operating system according to the CMOS settings. Which hard drive you boot from is customizable. For instance, you can tell it to look for the primary hard drive or maybe boot from a CD-ROM or a USB. This is all configured in the CMOS setting. Once you identify what device to boot from, whether it's the floppy, CD-ROM, or hard drive, it tries to load the operating system by looking for that boot sector. Once the boot process begins, control is now handed over to the operating system. Some more modern BIOS allow the PC to use what's called a pre-boot execution environment. You'll hear it called a PXE boot. What it does is it allows you to boot the PC without any local storage. This you'll usually run into when you're dealing with virtual environments. We'll talk more about that later. So as you can see, the BIOS and CMOS are essential to a proper running PC. So how should you care and feed for those? Well, remember, the CMOS is volatile. It must have power at all times, or it will simply reset everything back to its default. Some of the more common errors that you'll find with CMOS settings are configuration mismatches, or the date and time is not set, or possibly it's booting from the wrong device. If you notice your CMOS settings are not being held, the first thing you should probably look for is a faulty power supply, or maybe you got an electrical surge. After checking those and your settings keep resetting themselves, try replacing the battery. Here's a look at what the CMOS battery will look like, kind of like a little watch battery. So remember, your BIOS is held on what is identified as flash ROM. It can be reprogrammed from time to time. However, you should only flash the BIOS when absolutely necessary. To do this, you'll download the program from the manufacturer website and then just simply follow the instructions. Never interrupt a computer in the middle of flashing its BIOS. There you have it. It's pretty simple. Remember, everything starts with the basics. Once you have these understood, everything gets a whole lot easier. If you have any questions or even just a comment, feel free to leave them below, and I do read each and every one of them. I'll see you next time.